Yes, we see your screen.
Yes.
Okay, we can start now. Good morning, good afternoon, and good evening to all of you, depending on where you are joining us from. Welcome, everyone, and thank you for being with us live today, as well as those who will be listening to the recording later on. It is my pleasure to welcome our distinguished guests, who we will briefly introduce shortly, a little bit later. This digital event is organized by the International Pharmaceutical Federation, more precisely, with the help of Board of Pharmaceutical Science and in accordance with FIT education. Our webinar today is titled Visible Learning in the Age of Artificial Intelligence, the role of objective structured practical examination in pharmaceutical science. In this session, we will explore the role of OSPEs, showcase them in action, and provide clear practical guidance on how to successfully implement them in pharmaceutical science education. My name is Emina Becic, and I'll be your co-moderator for today's session. At the same time, it is my pleasure to introduce the chair of this session, Professor Dr. John Piper, and I would now like to invite him to introduce himself.
Thank you, Amina. I'm delighted to chair our session today. My name is Dr. John Pieper. I'm President and Professor Emeritus at the University of Health Sciences in Pharmacy, and I'm also currently serving as the Chairman of FIP Education. We have a distinguished panel.
Thank you, John, and I'll continue with some announcements, and
Okay,
then we
yes.
will continue with our panelists, but I have problem with slides. Okay, I have to stop sharing and then share my presentation again. Okay, sorry for this. So can you see my slides now?
Yes.
Okay. Thank you, John. I will now continue with a few announcements. Please note that this event will be recorded and live streamed on the FIP YouTube channel, and the recording will be available at events.fip.org. To all those listening, please feel free to send your questions through the question and answer box, and we will do our best to manage all of your questions. You are also welcome to provide feedback of webinars at www.fip.org. I would like to use this opportunity to highlight the benefits of FIP membership, including access to event and webinars. FIP is a global organization representing over 4 million pharmacists and pharmaceutical scientists. If you are a pharmacist or pharmaceutical scientist and would like to become a member, please feel free to register on the FIP website at fip.org. FIP has introduced some new in webinars, a live translation features on Zoom. If you'd like to try it, here is how it works. First, turn on your captions. Second, enable the translation option, and third, choose your preferred language under option My Caption Language. This way you can follow the session with live translate captions. So John, I give the floor and word to you so you can continue from this slide, and that's it.
Thank you, Amina. Again, welcome everyone. If I could have the next slide. The learning objectives for today's seminar are to recognize the relevance of OSPEs in the age of generative AI, where authentic demonstration of skills is essential, to gain a better understanding about OSPEs and their role in pharmaceutical sciences, to learn how OSPEs enhance visible learning and support lifelong competence development, and to be equipped with practical, actionable strategies on how to implement OSPEs effectively in your curricula. So again, welcome. I've introduced myself. I'd like to quickly introduce our co-moderator, Amina Becic is a senior, okay, let me find my intro, is a teaching and research assistant at the Faculty of Pharmacy, University of Sarajevo, where she contributes to teaching and learning and research in pharmaceutical chemistry. She's also pursuing a master's degree in business analytics at the faculty at University of Sarajevo. Our first speaker today, who will be speaking on collaborative innovation, adapting collaborative innovation, adapting clinical assessments for pharmaceutical science education. Dr. Betty Extenaris is an associate professor at the Faculty of Pharmacy and Pharmaceutical Sciences, Monash University in Melbourne, Australia, and currently serves as Associate Dean, Learning and Teaching, and Associate Dean for Equity, Diversity, and Inclusion. Over her 25 years at Monash, she has taught thousands of pharmacy students and pharmaceutical science students with a focus on skills-based training, student engagement, and supporting diverse and inclusive leadership. She has won a number of teaching awards, and she currently serves on the executive committee of FIP Education as our science expert. Next slide. Our second speaker today is Dr. Nilushi Karunaratne. She is a senior lecturer also at the Faculty of Pharmacy and Pharmaceutical Sciences at University of Monash in Melbourne, Australia. Her impact on student learning has been recognized by a number of teaching awards as well. She has received both national and international awards for her teaching, and she has been actively engaged in teaching pharmacy and pharmaceutical science students. She'll be talking about assessing applied knowledge, embedding OSPEs into large-scale pharmaceutical sciences curriculum. Next slide, please. And so without further ado, I am turning the podium over to Dr. Betty Extenaris.
Thank you so much. Next slide, please. Thank you. Thank you so much, John and Amina, and also Albina in the background for all your hard work. Good evening. Well, at least it is evening for us in Australia. So I'll start again and take a leaf out of Amina's book. Good evening, hello, and good morning to everyone joining us from wherever you may be based in the world. My colleague, Nilushi, or Nell as we call her, Karunaratne, and I are absolutely delighted to present at the launch of the Pharmaceutical Science Education webinar series along with FIP Education. I thought it was also worth mentioning my role in FIP. I sit on the board of Pharmaceutical Science as a pharmaceutical science educator. With that in mind, I wanted to let you know that the topic of the webinar will also feature in the next BPS newsletter in the Science Education corner, so please look out for it. In this series, what we really want to do is bridge our learnings in education across pharmacy and the pharmaceutical sciences, what we have learnt and what we can learn from each other. This evening, we will talk about OSPEs, or Objective Structured Practical Examinations. From the outset, we'd like to say that OSPEs can address the question about whether our students are still learning in the age of generative AI, something I'd like to say that most educators are grappling with currently. OSPEs are also an inclusive type of assessment which are accessible and can be implemented on a small or large scale and as simply or complicated as you wish. I will begin the presentation by talking about what the pharmaceutical science educators have learned from the pharmacy educators and other health professionals with this type of assessment, that is OSCEs. Next slide, please. So OSCEs, or Objective Structured Clinical Examinations, aren't new. So over 10 years ago, the Association for Medical Education in Europe published a two-part publication about objective structured clinical examinations. The first publication is about a historical and theoretical perspective on OSCEs, and the second part was more geared around organisation and administration. Of course, there are many educators in FIP who have also published some wonderful articles about OSCEs as well. And we might hear from Amina and her experience with OSCEs a little bit later on, time permitting. Next slide, please. More recently, in this article, which is led by Dr. Angelina Lim, a senior lecturer in our faculty, the authors review OSCEs over a 20-year period and in fact mentioned that OSCEs were first introduced in 1975. I won't let you know whether I was born around then or not, so I'll just continue. What was summarized really nicely in this paper and what we know about OSCEs is that they are firstly widely used to assess clinical competence, which is a relatively authentic form of assessment. We know that in some disciplines, OSCEs are used as a predictor of readiness for practice. We know that OSCEs test multiple skills, so both clinical and communication skills. We know that there has certainly been growth in OSCE use in pharmacy education, although some research, and some recent research really, has suggested that they're quite expensive to run. And over time, there has been a shift from perhaps their initial intended use in registration exams to being embedded across curricula. Next slide, please. So although this is a little bit off topic, I thought it was worth mentioning an innovation that can be used to support students in their preparation for OSCEs, and that's ATLAS. It's a very clever acronym. So it stands for Authentic Teaching and Learning Application Simulations. So this innovative platform was developed at our university, Monash University, which was really spearheaded by Dr. Joel Moore to enhance the preparation of students for clinical assessments. From our faculty, Emily Stokes and also Dr. Angelina Lim have really led this project. Just to tell you a little bit more, Atlas leverages generative AI to simulate realistic clinical and communication scenarios, really allowing students to practice and receive real-time personalized feedback. So this approach aims to improve both clinical reasoning and interpersonal skills, and students can practice in their own time. The platform has been positively received, with students reporting improved confidence and competence in handling various clinical situations. I'm sure you'll hear a lot more about this innovation in the future. Next slide, please. Okay, so we've spoken a bit about OSCEs, but what we haven't spoken about is what do they look like? What does a skeleton of an OSCE actually look like? So a typical OSCE, an objective structured clinical examination, is set up like a circuit of short structured stations where students rotate through and are assessed on different skills. So there are various stations. Each station is a time scenario, commonly 5 to 10 minutes. Students move through multiple stations in sequence. There are various scenarios. They can be practical. So in the medicine space, there might be a physical examination. They can involve dispensing, even aseptic techniques, or they can really be communication-based, so involving patient counselling, explaining lab results, or history taking. There's usually a structured marking scheme, which takes a long time to put together. So assessors use checklists or rubrics to ensure fairness. Marks are awarded for key steps, for accuracy, for professionalism and communication. The environment involves stations, which are usually set up in small rooms or cubicles, and a bell or signal. So somebody's either ringing a bell or posing some sort of signal to indicate when to move to the next station. And the purpose of the OSCEs is to assess application of knowledge in practice-like settings, not just theoretical recall. So in summary, students rotate through a timed circuit of stations, each testing a specific skill assessed against a standardized rubric. Next slide, please. So OSCEs are one way of assessing skills in healthcare sciences, and they've been around for a long time, as we've just established. So in the pharmaceutical science space, what have we been using traditionally to assess students? And number one would be written exams, end of semester exams, generally weighted quite heavily, often 30, 40, 50. I've even heard of instances up to 70%. Oral presentations, which are usually assessed during the semester. Laboratory hands-on skills, again during semester and probably less common. Laboratory reports, again very common and assessed during semester. And the purpose of these types of assessments have been mostly about assessing application of knowledge and theoretical recall with potentially some lab hands-on skills. Now, going back to what I said at the beginning of this presentation about making learning visible in the generative AI era and taking into consideration everything that has been done and researched in the OSCE space, coupled with the fact that assessment of the practical and theoretical skills of students is of importance in pharmaceutical science education, it made sense to consider the implementation of OSPEs in our context. We wanted to ensure that students had an in-depth understanding of concepts and were able to apply their required knowledge. So a typical OSPE, objective structured practical examination, is similar in spirit to an OSCE, but the focus is on laboratory and practice-based skills rather than direct patient interaction. OSPEs can be used in pharmaceutical science, in biomedical science, and laboratory-based disciplines generally. Here's what OSPEs look like. So once again, we have stations. They're timed structured stations. They can be 5 to 10 minutes each, and Nell will talk to you about an example of having a station that was about 30 minutes, in fact. Students again rotate through several of these stations in sequence. There are focus areas, laboratory techniques is one of them. So for example, pipetting, titration, calculation. So it could be about drug doses, concentrations, dilutions. It can be about data handling, interpreting experimental results, plotting graphs, or safety and quality control procedures, which really aren't assessed enough. The assessment format. So some stations require hands-on skills, for example, performing some sort of procedure. And again, Neil will put all of this into context a little bit later. Others may be written or observational, for example, answering questions based on given data or identifying errors in an experimental setup. Marking is completed with a structured rubric once again. The environment can be a laboratory or a skills lab. So you can use a bench or a station for each task, depending on how you're setting it up. And again, there'll be somebody with a bell or a signal to prompt students to rotate. Now, the purpose of OSPEs is to test the ability to apply theoretical knowledge to practical tasks. So it ensures competency in lab and technical skills, not just written exams where you can't test that. So in short, students rotate around lab-based stations, performing technical tasks and answering applied questions assessed using a standardized rubric. Okay, next slide, thank you. So the main difference between OSCEs and OSPEs gets a little bit tricky, doesn't it? There's a C in OSCEs and a P in OSPEs. Other than their intended audience and perhaps the skills they're assessing, is that OSPEs haven't been around for as long. So for example, a quick search of the literature shows you a few articles on this slide that have been published in the last few years. So in this paper in particular, next slide please, the authors nicely describe the intended purpose of OSPEs and their advantages over more traditional assessments. So OSPEs use practical scenarios and workstations to assess technical skills and decision-making. OSPEs involve direct observation of student performance at stations, so you know that they're competent and doing the task. OSPEs involve pre-established criteria and grading rubrics, which ensure a consistent and fair evaluation. OSPEs go beyond traditional tests. They offer a more accurate and balanced assessment. And finally, OSPEs cover higher levels of Miller's pyramid. So it's not just about the nose knows how to do something, but also they can show how to do something. Next slide, please. So in 2023-2024, we decided to pilot a trial OSPE in the pharmaceutical science space and the biomedical science space, spaces which are non-vocational. This paper, which was led by Nalusha Karinaratne, who's on this call, and Angelina Lim, who I mentioned before, describes a pilot of a 4-station objective structured practical examination designed to prepare students for the workforce. So very briefly, what we found was that the station involving relaying new drug information to a medical practitioner was an easier task for students than explaining the clinical implications of a drug to a medication professional. Post-OSPE focus group data revealed that students appreciate the need for OSPEs in non-vocational degrees, stating that the conversational mode of delivery is a skill they rarely have the opportunity to get to practice or receive feedback on, and it's obviously vital for the workforce. So, following on from this study, we decided to replace an end-of-semester written exam worth 40% in a pharmacology unit in a second-year pharmaceutical science degree with a 3-station OSPE. This initiative was led by Nalusha Karinaratne, and I'll hand over that she can tell you all about it. Thank you so much. Over to you, Nell.
Thank you so much, Betty, and thank you to the organisers for this invitation. Hello, everyone. So building on the fantastic focus that Betty has just provided regarding collaboration and innovation and adapting clinical assessments, I would like to now take you through a specific case study where these principles were put into practice in a somewhat large undergraduate type of unit. So in Betty's presentation, she spoke about why we may need to rethink assessments in pharmaceutical science. I will be focusing on how we embed OSPEs into a large cohort. So to give you a picture of where this work sits and some context, I'll be talking about a 3-year Bachelor of Pharmaceutical Science degree and one subject, or in Australia here, we call these subjects units, a non-clinical unit, however, one that is highly applied, has numerous laboratory-based learning activities and hands-on skills embedded, and one that is real-world and industry-focused. So within this 3-year pharmaceutical science degree, OSPEs was implemented into a second-year pharmacology type unit. This was a core unit, so every student within the second year level of this 3-year degree did this unit, and so every student at the end of the semester sat through an OSPE type of assessment. When we implemented this OSPE, which took place earlier this year, we had 164 students, and this number will likely grow in the coming years. So historically, this unit used to have a 40% written exam, and while it assessed knowledge and recall and application of knowledge and reasoning, it did not touch on any hands-on skills despite some smaller assessments during the academic year. So at the very end of this unit, it was focused on a written type of exam. So that was really the starting point for us. It had great theoretical knowledge and application, but there was no mechanism for us to really assess whether students could transfer that and apply it in a practice examination type setting. And that is the gap that led us to redesign this particular assessment model. So on this slide, I will start off with telling you about what happened in the end. After we did this type of assessment with a large scale cohort, what did the students think? So on this slide, on the left-hand side, we have a question and some data showing us what students thought of the fairness of this type of assessment. Something that they were very much not used to. Most of these undergraduate students within the 3-year pharmaceutical science degree are quite used to having written type end of semester exams, and so this was a big change for them. So you see on the left there, most students rated this new assessment type between 4 out of 5. There was a strong cluster at 4, and a very small number of students also happened to rate it low. This was important information for us for the first time having made such a big type of change, because whenever we introduce new types of assessments into the curriculum, especially ones like this, where for students it is high stakes, we need to know that students still see this type of large change as being one that is legitimate and equitable. So we got some idea of this from this feedback. The graph on the right-hand side shows alignment with learning and what they thought of this. About 60% of students rated it well or very well. Very few students felt it didn't match what they learnt. So overall, we took this as a strong signal of both student outlook on fairness and authenticity, students recognizing that this type of assessment actually matched what they were doing during the semester, rather than feeling disconnected to the activities, the laboratory activities they might have done during that unit. Next slide, please. The two graphs here were quite, I would say, even more insightful. So not looking at perceptions of fairness, but what was their experience of doing an OSPE compared to the assessment type they were used to, which was written exams at the end of a subject. In terms of anxiety and confidence, the graph on the left, you can see students felt quite highly anxious, not unexpected, and that seemed to have an effect on confidence. I should say the data we are presenting here was collected immediately after students had sat this OSPE exam. So they didn't necessarily have a lot of time to process their emotions. They sat the exam and we wanted a snapshot of their real, authentic, realistic feedback then and there on the day. So a subset of students felt very much anxious. So yes, this type of assessment is a highly anxious, perhaps pressurized environment. That is not surprising. You are being observed, the student is being observed, they are having to physically move between station to station, and it was not a format that they were necessarily used to. What was encouraging for us, I think, is the graph on the right-hand side, the educational value. Despite students recognizing that it was a highly anxious situation, you can see the graph on the right-hand side, the vast majority of students commented or felt that it matched or had much more educational value to them compared to a written exam. So the picture is, yes, students felt nervous and anxious, but they did also see this assessment or this large assessment at the end of a subject as being more authentic, being more useful, being more educationally valued. So this was a trade-off we made, and fortunately it seemed, we have only trialed this year and implemented this in a large scale like this year, and they also seem to think that trade-off was beneficial for them. Next slide, please. When we asked students what they found most challenging, 3 themes emerged. Timing. So for the students in real time, so very similar to pharmacy students and OSCEs, timing feels very real. Time moves very quickly. So in an OSPE situation, one of their stations was conducted in a laboratory setting. So time felt as if it moved very quickly. So that theme came out very much so in the qualitative data. Students weren't used to always explaining or articulating scientific concepts out loud, and that theme came up, as did the fact that they at times found calculations and verbal prompts trickier to address in real time. Next slide, please. We also asked students what surprised them about this experience. Again, Not surprisingly, the speed at which these stations moved seemed to come as a big surprise to students. I will say these students had multiple opportunities to practice this exam setting during the academic year too, but despite the 2 instances of practices we gave them, these types of comments still came up at the end. Students mentioned the depth of knowledge being tested, and they were surprised at the level of depth that was being tested. And they pleasantly commented that the examiners and the staff made that environment as calming as possible for them. So they acknowledged that while it did stretch them, the tone and structure of the OSPE helped them feel supported and engaged in the learning materials they had in this type of pharmaceutical science subject. Next slide, please. So I'd like to step back a little bit. That's what our students thought, but why did we change in the first place? Our core driver was to, in the age of generative AI, it is becoming more and more difficult to, hand on heart, say what our students know or don't know. And for us, this was a way of adapting something that has been taking place in a clinical scenario very well and for a long time, the idea of OSCEs, and adapting it into a pharmaceutical science context that would allow us to make learning in our students visible to us. So we had these laboratory-based units where students were engaging in practical laboratory tasks during the unit. They were practicing these skills. However, we didn't necessarily assess them in an exam type of setting. So this shift was very intentional. We wanted to look at what students knew, but also their ability to reason, their ability to perform evaluative judgment, critical thinking, problem solving in a very real and authentic context. We were also very intentional about explaining our thought process to the students. So all the way throughout the semester, we kept having this conversation with students about our rationale for this change. So this assessment, thank you. So this assessment had 2 types of stations: practical stations and application or reasoning type stations. So what you see there on the slide is the 3 boxes. Station 1 was geared towards hands-on practical skills. So this station directly assessed safety, laboratory safety, I should say, laboratory accuracy, and experimental planning in action. Station 2 and Station 3 were not hands-on stations. They were more verbal type stations, verbal consultations. So in these stations, students were able to defend experimental decisions, and in Station 3, they were allowed to articulate or explain laboratory concepts. And I'll explain each of these stations a little bit more in the next few slides, but I just wanted to say these 3 stations together allowed us to move to a holistic assessment of practical skills, reasoning, and communication, all in the one type of assessment. And I'd like to go back to the point about making learning visible to us. This assessment made that learning in a student visible to us in the age of generative AI, where sometimes that's not as easy to do anymore. Next slide, please. I'll spend a little bit of time now showing you the types of tasks that students engaged with at these 3 different types of stations, and also how they were assessed. All of these was done from our learnings from what has happened in the pharmacy space with the OSCE type assessments that Betty spoke of in her presentations. We have taken those learnings and adapted it into a pharmaceutical science context. So in the practical station, next slide please, in the practical station, students had 10 minutes of reading time followed by 30 minutes in the lab. In these practical stations, we assessed 3 key abilities. Firstly, their ability to work safely and effectively in a laboratory environment. So the task, an example of the task that they had to do was check how they could apply a risk assessment or safety procedure to see if they could understand and apply that knowledge into a question or scenario that was given to them. Secondly, their ability to design a simple experiment and carry out that experiment. So what I mean by simple is something as simple as, for a pharmaceutical scientist, looking at the effectiveness of a drug, for example, the ability to carry out a set of dilutions and follow instructions and articulate calculations. The third skill we assessed in this practical hands-on station was analysing and evaluating data. So students were given some example or mock type of data, and they would be required to interpret, evaluate, and draw conclusions from that data. Next slide, please. For this practical station, how did we assess students? So students' performance was captured and assessed in two ways. Through written responses that was collected in the form of a worksheet at the end of their station, but also through direct in-person observations. So there would be examiners in the space with the students, observing them as they carried out these tasks, and a objective structured checklist, such as the one that I've shown an example of there, would be used to objectively mark off these observable behaviours in the students. Both of these criteria was then used to assess practical station 1. Next slide, please. For the next two stations, as a reminder, these were the two verbal consultation stations. These were intentionally structured to make students' thinking visible. The questions and scenarios students worked on for these stations related directly back to the in-semester practical labs that they conducted. Station 2 looked at their ability to interpret and justify experimental data. So they would be given a sample experimental data, 5 minutes of reading time before the examiner would commence a conversation with them. They were then asked a series of questions about the design, analysis, and interpretation of the experiment. So like I said, while this is sample data given to them, it links back to activities that they would have done earlier on in that subject. Station 3 was the explanation of a concept, again, from one of the laboratory learning activities they would have done earlier. This allowed us to assess clarity of understanding of those concepts, their ability to scientifically communicate, and their ability to connect practice back to theory. So together, this gave us a real insight into the students' ability to reason. Next slide, please. For the two verbal type of stations, how did we assess them? Again, we made the use of an objective structured checklist. Some examples are shown there on the slide. We looked at specific observable characteristics such as scientific reasoning and their ability to justify their decisions. And to ensure consistency and fairness when assessing, we used examiner training and numerous rounds of iterative processes with the examiners. Next slide, please. I'd like to now, over the next two slides, tell you a little bit about what this looked like to run with over 160 students. There were lots of things that required planning. This included timetabling and modelling the flow of student movements between stations. As I said, examiner training was tremendously important and cannot be undervalued. To ensure the objective structured nature of an assessment like this, examiner training becomes vital. Consistent rubrics is also extremely important. A lot of time and investment went into trialing these rubrics, receiving feedback from the examiners, and then putting that feedback back into action. There were also pressure points that I won't go through today, but some of those are mentioned on the slide as well. Next slide, please. To keep 164 students and nearly 30 examiners coordinated across 3 different stations, on the day of the exam, we relied on a live web page that was created through freely available resources online. It just became a one-stop location for examiners, tutors, and students to keep rosters and everything else in one place. Next slide, please. When designing OSPEs, I just wanted to highlight that we intentionally also built in inclusivity into this assessment itself. The structured nature of prompts helps reduce ambiguity for students and gives all students a very clear starting point. And this particularly supports our diverse types of students that we see in our cohorts. The materials were also made accessible. What I mean by that is, I mentioned that students had 2 instances to practice this type of assessments with no grades associated with them during the semester. Both of those 2 instances, I received feedback from my students and they gave me some very valuable feedback. I'll share one story with you. Students requested for a blank piece of paper and something to write with that would help them structure their thoughts as they read that scenario or looked at that experimental data set during reading time. That was not something I had accounted for, but given that students requested that, I saw no reason not to work that into the final version of the exam, and that's exactly what happened. So importantly, students had multiple ways of showing their understanding in this type of assessments through practical doing in the lab using hands-on skills, but also through verbal explanations and also through drawing or writing on the blank piece of paper. So together, these choices, I feel, really brought in a fairness aspect, an ability to support, as I mentioned earlier, a diverse cohort of students. On this slide, I'd like to end with what happened with this large-scale OSPE. So 164 students. By the end, the average for this end of semester assessment was just over 70%. Students found Station 1, the hands-on station, the most challenging. Overall for this assessment, our fail rates looked to be around 8% of the cohort. And very interestingly for me, that wasn't significantly different from previous years. However, my confidence in my students and my confidence in their knowledge and their abilities was a lot more perhaps than in previous years. Again, because I was able to visibly see the learning that they had achieved over the year. The OSPEs overall worked well, but there are definitely some key refinements that we would make going forward. And in closing, I want to say that OSPEs shows us that assessments can do a lot more than just testing knowledge. They can foster authentic learning, sharpen decision-making skills, and promote inclusivity in diverse student cohorts all around the world. The bigger conversation for us in our context where we are is now considering how we can link these stations to perhaps core concepts of pharmacology, but I won't say any more than that. Perhaps that's a story for another day. And with that, I would very much like to take a moment to acknowledge the very many people that made this large-scale OSPE possible, from the teaching team to the technical staff to the examiners and facilitators. And with that, thank you so much for listening, and I'll hand back over to the moderators.
Thank you to both Neil and Betty for brilliant presentations. I think this is a real milestone in our assessment of pharmaceutical sciences education. And thank you to both of you for bringing this to us. I'd like to maybe provide Amina with the opportunity to make a couple of comments about her experience with OSPEs, and then we'll start with Q&A. Amina?
Thank you, Neil and Betty, for this great presentation and for all the news I heard. So I want to share my experience about OSCE, but after listening the presentation, I think at my college we have some kind of mix of OSPE and OSCE. Probably they do not have right tutors for OSCE. So after this presentation, I'm not sure do we have OSCE or OSPE, but I hope we will have the OSPE because it seems more interesting and more practical to students comparing to OSCE. So, what is my experience and why I think this kind of exam is good? Because while I was studying, we do not have any kind of practical exams. and we do not have the chance to practice the communication with patients. We all know the theory, but we do not know how to use that theory. For example, I have the situation in pharmacy where the patient come to me and they ask me, okay, I have to take statins, and he asked me, okay, in which part of day I will take it, and I was okay, I'm not sure, and then I asked the older colleague, and she said, oh, before going to bed, and I was okay before going to bed, and then I stand and I was okay. I know the cycle of cholesterol synthesis, but I forgot that they should take the statins before going to sleep, because the cycle of production, the cholesterol, is the most before the night. So I think that these kind of exams are really important, and that they prepare students and all of us for real world situations. And I hope at my university and at my college we will go from OSCE to OSPEs, because it seems to me a little more practical and maybe less stressed for students, and more useful. So thank you for sharing with us these new insights of how to move from theoretical knowledge to practical knowledge.
Thank you, Amina. We have some questions in our Q&A box. Again, I would encourage everybody, if you have a question, we'll try and get to as many as we can. We have about 13 or 14 minutes left in the session. So I'm going to start with a very good question from Rebecca Isaacson. What is your best advice for a university or a faculty member, a lecturer, looking to implement OSPEs in their teaching program? And what are some good resources around the world, or from you and Monash, to help support faculty members in this process? Let me turn that over to Betty initially.
Yeah, thank you very much, John. I was going to say I'll start off and then hand over to Nell. But I think the best advice we can give you is probably to do something similar as we did on embarking on this journey of OSPEs. I would advise to start off small and actually pilot the OSPE in your context where it's not worth any marks. You know, get a sort of group of students together, give it a go and see how you go, because I feel that we learned a lot from that process and we received fantastic feedback, not only from the students, but also from our examiners. And so that meant, firstly, that we could publish that pilot. So please feel free to look that up. Some great reading material, if I do say myself. But on top of that, we could use this information to implement into Nell's context, where she wanted it to be not a formative assessment, but a summative assessment. Something else that I think is probably important is that to allow students to be able to practice the OSPE as well. So to start off small, to pilot it, and then when you are going to run it in your unit, and again, you can do it on a small scale, you can do it on a larger scale, you can have one station, you can have two stations. It doesn't have to be an enormous examination, but give students the opportunity to actually practice. And I think they really valued that experience. So I might hand over to Nell, who can talk a little bit more about that. The only other thing I'll say in terms of resources, I had downloaded a number of papers in our slides. They're very good papers to read about a couple of different experiences from around the world. So I'm not sure whether our slides are circulated, but I'm certainly happy to give you the links to those papers, including our own, because I think they would be a very good starting point, because they really, I don't know, there are quite a few contexts that are covered in those papers, I guess. Over to you, Nell.
Thanks, Betty. I will just add just one more thing for that question, which is I would very much go back to your intended learning outcomes for whichever context you might be approaching this from. So this type of assessment is fantastic where you want to see and have confidence in what your students know or can do. There are lots of types of assessments that are suitable for a science context or a pharmaceutical science context. This type of assessment is very valuable for that knowledge you want your students to know without relying on other resources. So I say that because in this age of generative AI now, that is not necessarily the case for all types of knowledge or all types of skills. We are very much having open conversations with students about how they should know when and where to access generative AI or use it or work with it, and so forth. This type of assessment removes the generative AI lens, and you would use this type of assessment where you want to have confidence of what your students know, and that comes back to what learning outcomes you are hoping to your students to have achieved by the end of that subject.
Yeah, that's a very good point, Nell, and maybe map a skill or a competence to a learning outcome. And for each station, don't try to overcomplicate it and assess multiple learning outcomes, but perhaps one per station as well.
Another question that has come is from an anonymous attendee saying, I'm struggling to find the difference between OSCEs and OSPEs. I've been assessed with OSCE before, and I'm not really getting the difference. I think this is an important point. Betty, do you want to approach that?
Yeah, sure. So the main difference is that the objective structured clinical examination, sort of typically if we're using a pharmacy context where, I've been both an examiner and a simulated patient as Nell has, you're moving station to station, and generally those stations, as you would know because you have experience with OSCEs, are set up like a pharmacy. So typically you would have your student coming in and saying, hello, I'm your pharmacist, how can I help you today? And they would have a patient there describing some sort of condition, taking various medications and having various allergies or whatnot, etc. And it would be up to the student who was being assessed or examined to actually, counsel the patient, give them advice, refer on to a medical doctor, for example, if they felt that that was necessary, etc. So OSCEs are really clinically focused and tend to be used in healthcare in the pharmacy context or the medical context as well. So faculties of medicine also tend to use OSCEs as well. OSCEs can also be scaffolded from a sort of first year level right through to a fourth or fifth year level. OSCEs can be used to test other skills as well, history taking, taking blood pressure, etc. So they're really clinically focused. Okay, and that's very, very important as healthcare professionals, whether you're a medical doctor or whether you're a pharmacist or you're an OT or something, you're more likely to experience OSCEs as a student. OSPEs, it's all about a practical examination. So, for example, in Nell's context, and she can talk to you about it in more detail, we have our students coming into the laboratories. We ask them to write up a laboratory report, but we don't really know, do they know how to pipette? I mean, that might, that something as simple as that could be very, very important, for their, the next part of their career, right? Can they pipette accurately? Do they know how to use a plate reader or whatever it is that you'd like to assess so that you can confidently say they know how to do that? Or do they know how to interpret data and they're not just plugging it into ChatGPT? You can give them some data to analyze then and there without generative AI, without any resources to tell you what do they think of that data, what are the main take-home messages, or even safety, which again is something that Nell had as part of her OSPE. Do they know how to read some sort of, safety data sheet, for example? Do they know how to interpret it? Or if, maybe if they're in a third year of a pharmaceutical science degree and, they want to be a pharmaceutical scientist, or they might want to work in industry, can they actually communicate what a drug does in layman's language to a medical professional? So there is some overlap, most definitely, but I feel that they're quite distinct.
Thank you, Betty. Another, I think, really insightful question is, were your examiners compensated? How long was their training, and did they provide feedback, which I'm sure they did? But talk a little bit about examiner recruitment and training.
That one's for you, Nell.
Yeah, of course, of course. That's a great question. So I might start off with the OSCE context here. So at our faculty, pharmacy OSCEs have been taking place for more than 10 years, and it is a well-established form of assessment. We have a large team of examiners that includes both teaching staff and externally sourced simulated patients, and they do get compensated for their time, especially if they are external to the university. Now, this is the first time we have adapted that clinical type of assessment to a science discipline. And because of that, we did not have a budget as such. And so for me, I very much had to rely on teaching staff here at the university. And so when this was done, those individuals, so the teaching staff at the faculty, were compensated in terms of our workload. So not monetary compensation, however, workload compensation for the time that they took out of their normal roles to assist with this assessment task. That's how they were compensated. Just in terms of the other part of that question, I need to really highlight how important it is to rigorously and sufficiently train the examiners for this type of assessment. And that is the same for OSCEs or OSPEs. The common thread, there is, as Betty said, there is overlap between the two, but the common thread for this type of assessment is that it is an objective type of assessment. You are trying to limit as much bias, introducing as much bias through the individual examiner, which is why a lot of time and planning and testing goes into developing objective structured checklists. So it might not have been clear from my slides, but those checklists that the examiners use are not a rating. They are a very discrete yes or no. A student either demonstrates or does not demonstrate. And so because of that, it is a different type of assessment. So no bias is introduced from the examiner's end where they are interpreting the student's performance. It is an observable trait or skill or hands-on action that they are doing, especially in a laboratory setting. And that all comes down to training of the examiners, and feedback was extremely important. If we had not tested this out, I think we tested this out twice before the final examination, and we had examiners leaving comments, feedback, all of which we incorporated back to make it successful from our end in the end.
Yeah, and I might just add, Nell, so we had enough time to analyze all the student feedback in time for this seminar, but we haven't had enough time to analyze all the examiner feedback in time for this seminar. So you might see that in the future.
Thank you, Betty. And I think it's a follow-up question, and I think you addressed this a little bit, Nell, in your presentation. Did you see a difference in the students that passed the course or the grade they received using the OSPE system compared to the more traditional examination system that you had used before? Maybe a little more color around that if you could, Nell.
Of course. Short answer is absolutely. So students in general are very confident in their knowledge. So our students historically are very confident at studying for an exam and knowing what they know. This assessment tested a different skill set. We talked a lot to students the difference between knowing something and being able to action something or explain something or articulate something or in a real-time setting problem solve. And so those somewhat invisible skills were brought to the surface with this assessment. And so in hindsight, with the students that went through this OSPE this year, what again, we haven't looked into this in depth, obviously, yet. But what was apparent is their confidence too. As a chief examiner for this unit, I saw quite a big difference in the students' own confidence in their own abilities to do some of these tasks and use some of these skills that they hadn't actually used in the past. And so that was quite a nice thing to see, their own confidence increasing to be able to have confidence that they not only knew something, but that they could apply it in a different way into a new context that they had not seen before.
Thank you, Nell. I think we're ready for wrap up and conclusions.
Yes, I can continue from now because we are running out of time, if it's okay to all of you. So I would like to thank you all for joining us today. Thank you for this really new information about how to test the student knowledge and how to transform the written knowledge to practical knowledge. Thank you for sharing us really new informations about OSPEs. I would like also to say that this is the beginning of our digital events, which we organize with a help of World of Pharmaceutical Science, and that we will continue to organize the digital events which are similar to this. So feel free to join us. And at the end, I would also like to say that you can continue to follow the information about the future FIP digital events following the page events.fip.org. And at the end, I would also like to mention that the new FIP World Congress will be held in Montreal, Canada from 3rd August to the 2nd September in 2026. And I would like to express gratitude for our FIP colleagues from marketing and digital media team who supported us in planning this event. Thank you all for listening us and attending.